Okay, so if you've ever seen a movie or read a thriller like Angels and Demons, you've probably heard of antimatter, right? It's always the ultimate weapon or this crazy futuristic power source. But the real story of antimatter, well, it's a whole lot stranger and honestly more profound than any science fiction. This is a story that makes us question why we exist at all.
First things first, let's talk about the price tag. The best estimates we have put the cost of making just a single gram of antimatter at around $100 trillion. Yeah, you heard that right. That makes it, by far, the most expensive substance we can even imagine. But believe it or not, the price isn't even the most fascinating part.
So what is this stuff? In short, it's the mirror image of everything we know. An antiproton, for instance, has the same mass as a proton, but it's got a negative charge instead of a positive one. And when these opposites get together, they don't just, bump into each other, they annihilate. They completely vanish, converting almost all of their mass into pure, raw energy. It is literally the most efficient and violent energy release that the laws of physics even allow. So it's powerful, it's ridiculously expensive, but that's not the real mystery. That's not what keeps physicists staring at their chalkboards all night. The actual puzzle is much, much bigger. Because if you really think about it, given what antimatter is, our universe, and that includes you and me, shouldn't even be here.
You see, this whole problem goes back to the very first moments of time. Our best theories, the ones that explain the Big Bang, they tell us that it should have created matter and antimatter in perfectly equal amounts. But if that's what happened, every particle would have immediately found its antiparticle twin and poof, they would have all annihilated each other, leaving nothing behind but a boring, empty universe full of light.
For us to be here, for all the stars and galaxies to exist, there had to be a tiny little hiccup right at the start. The leading idea is that for every billion antimatter particles that were created, there were a billion and one matter particles. Just one extra. It was basically a cosmic rounding error that ended up making all the difference.
So picture this giant annihilation party at the dawn of the universe. All these pairs of matter and antimatter are meeting and disappearing in flashes of energy. And after all that chaos, when all the pairs had canceled each other out, what was left? For every billion pairs that were destroyed, there was that one lonely, leftover particle of matter, the lucky survivor.
And here is the part that should just absolutely blow your mind. Every single thing you see around you, this planet, our sun, every single star you can see in the night sky, all of it is built from those leftovers. We are all made of the cosmic scraps, the survivors of that 1 in a billion imbalance. Our entire existence is a beautiful cosmic accident.
So this little flaw, this asymmetry, it's the reason we're here to talk about it. And that's why scientists are on this huge quest to figure out why. Why was there an imbalance? And to find that answer, they have to find some deep, fundamental rule of physics that matter and antimatter don't follow in the exact same way. They're looking for a broken rule. For the longest time, physicists believed the universe was built on these three perfect symmetries. There was charge symmetry, which basically says if you flip a particle's charge, the laws of physics don't care. Then parity, which means the universe doesn't have a left or right preference. It looks the same in a mirror. And finally, time symmetry, meaning the rules work the same whether time is running forwards or backwards.
Everyone just assumed these rules were absolute, that they were unbreakable laws of nature. But back in the 1950s, a few bold physicists decided to ask a question that would completely shake up the world of science. What if one of these rules isn't really a rule at all?
That question led to this absolutely brilliant experiment led by the physicist Chien-Shiung Wu. What her team found was that for certain types of radioactive decay, the universe does play favorites. It actually prefers particles with a left-handed spin. And just like that, parity symmetry was broken. The universe, it turns out, is not perfectly symmetrical in the mirror.
I mean, this discovery was a huge deal. It was the first crack in that perfect symmetrical picture of physics, and it gave scientists a glimmer of hope. Could this be it? Could this tiny flaw in the rules, and maybe others like it, be the very reason for that 1 in a billion imbalance that allowed our universe to exist?
Of course, to answer a question that big, you need to be able to study antimatter up close and personal. But how on earth do you study something so incredibly volatile? Well, that takes us to the only place on Earth that actually makes this stuff on purpose, CERN's Antimatter Factory.
So you can imagine the main challenge here. It sounds simple, but it's almost impossible. You can't put antimatter in a jar,
right? Because the jar is made of matter. The second they touch, poof, total annihilation. So the real problem becomes, how do you hold a ghost without actually touching it?
The answer is this incredibly clever device called a penning trap. The best way to think of it is as a kind of magnetic bottle. Instead of using physical walls, it uses a combination of powerful magnetic and electric fields to just levitate the antiparticles in a perfect vacuum, safely keeping them away from touching absolutely anything.
So let's just walk through how this works. You start with a tube that's been pumped down to an almost perfect vacuum. Then you turn on a super strong magnetic field that lines the tube, which forces any charged particles, like antiprotons, to stay right in the center. Then electric fields on either end act like caps on a bottle, so they can't escape. You cool the whole thing down to just a few degrees above absolute zero, and there you have it, you've got a ghost in a bottle.
And you might be wondering, how well does this actually work? Well, the current record for storing antiprotons at CERN is a jaw-dropping 614 days. Think about that. That's almost 2 years of holding the most volatile substance in the universe perfectly still. It's just an unbelievable feat of science and engineering.
Okay, so we've journeyed from the Big Bang all the way to these super high-tech labs at CERN. Let's zoom back in now and bring this all back home. How does any of this cosmic mystery actually relate to you in your everyday life?
Given how powerful this stuff is, it's a fair question to ask. With CERN actually making antimatter, should we be losing sleep over an angels and demons type of scenario? Could somebody really build an antimatter bomb?
Let's just put it in perspective with some numbers. The bomb in that movie supposedly used a fraction of a gram of antimatter, but the total amount that CERN is able to produce in an entire year is about 1 nanogram. That's a billionth of a gram. The amount needed for fiction versus what's possible in reality, they're not even in the same universe.
In fact, to make enough antimatter for that one fictional bomb, at the rate they're going now, the Antimatter Factory would have to run continuously for longer than the current age of the universe. So, yeah, you can definitely rest easy. An antimatter bomb is purely 100% science fiction.
Okay, so if it's not a weapon, and it's so incredibly hard to make, does it only exist inside places like CERN, or can you actually find it somewhere else? The answer is yes, and where you can find it is probably going to surprise you.
You can find it right here, in a banana. See, bananas are full of potassium, and a tiny, tiny fraction of all potassium is a naturally radioactive version called potassium-40. And about once every 75 minutes or so, one of those atoms will decay and spit out a positron, which is an anti-electron, a tiny little piece of real antimatter.
And here is the final amazing twist. It's not just in bananas. Your body has potassium in it too, which means right now, as you're sitting there, you are producing about 180 positrons every single hour. This exotic, mysterious substance from the dawn of time, the stuff of science fiction, it's being created inside your body all the time. You haven't just been a spectator to this cosmic story, you've been your own little antimatter factory all along.